Welcome back, ladies and gentlemen. We're on 2.1, day 3. We're going to talk about some graphing shortcuts here today. Our objective is going to be graph equations without using those XY charts that we've been using up till now. Alright, so to hopefully figure out some patterns, I've got 3 equations where their XY charts are already there and the graphs are already there. But quite honestly, I'm more interested in the XY chart for now than the graph, but we'll get there as we go. Alright, now first thing I want to look at is for all 3 of these equations, we have kind of a number with an x and a number without an x over here by itself. I want to look at the one by itself first, because honestly that's the easier of the two to see the pattern. Okay, for instance, this guy's got a minus 7 here in the equation. Well, if I look next to my 0 in this guy, he's also got a minus 7. I see a positive 6 right here in this equation, and paired up with a 0, I see a positive 6. Positive 4 here in this equation, paired up with a 0 is a positive 4. Alright, hopefully that wasn't too groundbreaking for you, but here we go. Alright, now this next one is a little bit trickier, and I'm going to think about this number here as I do this, but what I really want to analyze now is how the x's change and how the y's change as we kind of work our way down the xy charts here. For instance, the x's here go 0, 1, 2. So basically from 0 to 1 that's going up by 1, 1 to 2 that's also going up by 1. Not a big shock there. Negative 7 to 4, okay, watch your negatives here, that's going up by 3. Negative 4 to negative 1 is also going up by 3. Alright, you may see something in that equation that looks something like what I just did, but here we go. Let's continue. From 0 to 2, of course, that's up by 2. 2 to 4 is also up by 2. 6 to 1, notice I'm dropping by 5, so I'm going to write that as a minus 5. 1 down to negative 4 is also a drop of minus 5. Okay, maybe those numbers look familiar to the original equation. And continuing on here, from 0 to 3, that's going up by 3. 3 to 6 also by 3. 4 to 5 is going up by 1. 5 to 6 is going up by 1. Okay, now notice the 3 and the 1, negative 5 and the 2, and then the 1 and the 3 are all represented by this. Notice the number in the y's is the number that's on top, and the number with the x's is the number on the bottom. Now here you might be freaking out saying, wait a minute, but remember, anytime you have a fraction, or you have a number, you can think of it as a fraction. So if I think of that as 3 over 1, well, there's my 1 in the x, 2 in the x on the bottom, 3 in the x on the bottom. There you go. Okay, so let's formalize that and write some rules, and maybe use that to do some graphing. Alright, now let's kind of formalize those patterns I was just talking about previously. Here we go. The number by itself determines a point on the y-axis. Okay, because again, it was always the point 0, comma number. And if I go 0, comma number, I go nothing left and right, and then I go up or down someplace on the y-axis. So wherever that guy is, whether it be up, be it down, or nowhere at all, I'm always going to be on the y-axis. So that's what I mean by that. Okay, we're going to consider this as a starting point for making our graphs. Okay, then the number with the x is going to determine how far you can count. For now, I'm just going to say up and over right here. You may have been thinking of other words, and we'll probably get to those words in just a minute. But that's how far you can go up and over to get to another nice point on the graph. And you might be familiar with the phrase rise over run, which is exactly what the number with the x represents. Alright, we have another name for that, but we're not going to use that here today. Alright, anyway, here we go. For the graph of y equals 3 halves x minus 5, you make a starting point, and again, here's the number that's by itself, at least based on what I just said. Okay, so we're going to put a starting point at 0, negative 5. Okay, it's always going to be 0 first, and then, again, up or down 5 based on whatever you see here. And then we're going to go up 3. It's a positive 3, so that's going to send me up 3. And then, instead of saying over 2, what I'm going to say, because that's a positive 2, I'm going to say right 2 in order to plot another nice point. Okay, if that didn't make sense, let's put it to the test right now with a real example. Alright, so here's that exact same equation. Y equals 3 halves x minus 5. Okay, now again, from what I just said previously, I just want to highlight a couple things. I'm going to start at the point 0, negative 5. So 0, and then 1, 2, 3, 4, 5. So down 5. Okay, and then again, what that 3 halves means is I can go up 3 and then right 2 before plotting a new point. So I'm going to go up 1, 2, 3 and right 1, 2, plot another point. And the beautiful thing about this is I can continue that pattern as long as I feel like it. So I can go up 1, 2, 3 again, over to the right 2, make another point. And again, I can do that all day, but for now, There you go. Okay, if you don't believe me, feel free to make a big XY chart, and once you plot those points, you should end up with the 3 points that I've given you right there, as long as you pick the 0, 2, and 4 that I would have recommended you picked. Alright, let's move on to another example here. I've got y equals 4/3 x plus 1. Okay, again, what that means is I'm starting at 0, 1, 0, 1, and again, this number right here means I'm going to go up 4 because it's a positive 4, and then also it's a positive 3, so that sends me right 3 before I make another point. 1, 2, 3, 4, 1, 2, 3. Nice point right there. Again, if I did an XY chart, I would have gotten that same point, but I'm just doing this faster. 1, 2, 3, 4, 1, 2, 3. Bang. Okay, again, if you don't believe me, stop the video, make an XY chart, and check yourself versus what I did. But that's how fast it should go if you know what you're doing. Alright, don't freak out if there's missing numbers. Missing numbers really are actually there, there's just sometimes we don't bother to write them in. For example, y equals x minus 2. Again, normally we think of that as a 1x minus 2, and since we're thinking about fractions in this problem, I would actually maybe even think about it as 1 over 1. Okay, so once I've done that, again, here's my starting point at 0, negative 2. Go down 2. And then again, since I've got a positive 1 and another positive 1, this means I'm going to go up 1 and then right 1 before I make my next dot. So up 1, right 1, and up 1, right 1. And again, if I wanted to, I could do this all day. I am not going to require this of you, but I could plot points for the next 3 or 4 hours if I really, really felt like it. I don't feel like it. Okay, here's another one that's got a missing number. So I've got negative 4x, and okay, if I'm missing a number in front of an x, it's always a 1. If I'm missing a number, which is basically just empty space, it's basically like having a 0 on there. So really this is negative 4x plus 0. And now using the same logic we were just using, that lets me know if my point is 0, 0. And then again, this is a negative 4 if I think of him as a fraction. Okay, now notice he's negative, so basically instead of going up 4, what this means is I'm going down 4. Notice though this is a positive 1, so that means I'm still going to the right, and in this case specifically it's going to be 1. So starting at 0, 0, there I am, and then again I can go down 4, 1, 2, 3, 4, and right 1, and then down 1, 2, 3, 4, and right 1. And again, with this nice pretty line drawn through there, I feel just wonderful about life in general. Now, hopefully you were thinking, wow, this is pretty easy, and I agree, it kind of is. Hopefully you weren't thinking, oh my gosh, this is so hard, but anyway, here we go. Equations aren't always written in a y equals form, so this does add a degree of difficulty wrinkle into what we just did, but here we go. The 2 basic steps for converting equations into that y equals forms are going to cancel the x term, that's a t, with either addition or subtraction, and then we're going to divide everything by the y term's coefficient. Again, that's the number in front of the variable. Okay, so moving on to this guy, I've got a negative 5x plus 4y equals 8. So again, I'm going to cancel out that x term. In this case, since he's negative, I'm going to have to use addition to get rid of him. So positive 5x on both sides. And again, make sure you don't combine like terms when they're not supposed to be combined. So I've got an 8 and a 5x. So again, since he's got an x and the other guy doesn't, I can't put them together into a 13 or anything like that. And now at this point, I've got to divide by the 4. Okay, and please again, 5/4 doesn't reduce, so don't turn it into a decimal. This is one case where fractions are far, far better to have than decimals. Although the 8 over 4, that does divide very nicely and become a 2. Alright, so again, now that I can do this, I can start at 0, 2, and then I can go up 5, right 4 to make my next dot, and then continue that pattern forever. Okay, so basically let's put that to use now. So once we've got the equations of y equal form, we can graph them normally. I'll call it normally. Normal means something different to everybody, so here we go. Alright, again, I'm going to subtract my x term, or in this case cancel my x term by subtraction, and then bring down the other stuff. Okay, a negative 5x right there, and then I've got a negative 6, so I'll just bring him down again. They're not like terms, so don't put them together. I'll divide off my negative 2, and boom, that leaves me with a y by itself. Notice the negative over the negative cancels out to be a positive 5 over 2. The x is just kind of along for the ride right there. And then negative 6 over negative 2 makes a positive 3. Alright, so in this case I'm going to start at 0, 3. And then again it's a positive 5 over positive 2, so I'm going to go up 5, and then I'm going to go right 2. Okay, now there's going to be one kind of magical wrinkle that happens here, but let's get there when we get there. 0, 1, 2, 3 is my starting point, and I'm going to go up 5, 1, 2, 3, 4, 5, and right 2, so I'm right here, but notice I very quickly run out of graph. So I don't have room for another one, so if you're so inclined, and I highly recommend this, maybe instead of going up and right, since lines go forever in both directions, you can go the opposite direction. And the opposite of up and then right is going to be down and then left. So instead of up 5, I can go down 5, and instead of right 2, I can go left 2. And if I make another dot, notice how all three of those still line up very, very nicely. So basically, if you run out of room, all you have to do is head back in the opposite direction, and you can generate more points in the other direction as well. Nice little trick. Of course, we've got our two weird cases to be careful with. Alright, the y equals negative 4. Again, if I wanted to, I could really think of this having a missing number as y equals 0x minus 4. Okay, because how many x's do you see there? Well, you see 0 x's, so you could actually write that in if you wanted. And then thinking of that as 0 over 1, I know this is not very normal here, but okay, I'm starting at 0, negative 4 as my starting point. That's what that guy means, because he's the number without the x. And now this number with the x means I'm going to go up 0, and then I'm going to go right 1. Okay, so putting this into action, down 4 for my starting point, and I'm going up 0, so I'm going nowhere, and then right 1. Up nothing, and then right 1 again, puts me here, and notice this gives me a nice horizontal line. Okay, my recommendation is actually just kind of get yourself to memorize that y equals a number is going to give you a horizontal line at that number, and maybe have to skip going through that thought process. Just my advice, but there it is. Alright, now our other weird case is the x equals case. Now remember, this is our exception to the rule, because basically I want y equals, and I sure as heck don't have it. Alright, so since I can't get my y equals, basically I think the best thing to do is memorize this guy, and this guy is going to give me a vertical line. Okay, basically the fallback position right here is going to be going through an XY chart again, and if you remember the XY chart for this guy, I basically fill in my X column with 3's, and then I can come up with any numbers I want. But again, what I would really prefer you do is just memorize that anytime I see an X equals, oh, that's just going to be a vertical line, and big shocker, it's going to be over at the X equals 3. So just go 3 in the X direction, which is to the right, 3, and then from there I'm going to get a vertical line, so just plot a couple points to help you draw yourself a straight line. And there you are. Today we've got 2 pages worth of try these. It fits on one sheet of paper if you printed them out yourself, but here's the first page. And here's the second page. Alright, good luck with these, and I'll see you in class.